Let me introduce to the concept of work. Work is an energy transferred to or from an object when a force is applied along a displacement. When a force is applied on a body, if this force result into a displacement of a body from one point to another point, then this is known as work. So in a simple word, if I define the work is force time displacement. Consider the body or having a mass m. Consider this is as a block and the mass of the block is m. Now if a force is applied like this on a block, and if this force result into displacement of this block, suppose this is position 1, if this force result into displacement of a block to a position 2, like 2, then this change in position of the block 1 to a position 2 is known as a work. So the change of a position of a block 1 to a position 2 of the same block upon the application of a force is known as work. This means that work W, which is represented by W, is force time displacement. Student, please keep in mind that work is a scalar quantity. Scalar quantities are the quantities, scalar quantity. Scalar quantities are the quantities which have only magnitude, and these quantities do not require direction. Some common type of scalar quantities are mass, time, density, etc. So distant, as you know that unit of mass is kilogram. Similarly, unit of time is second and unit of density is kilogram per meter cube. So this means that all these physical quantities like mass, time and density, all these physical quantities do not require any kind of direction. So you will never say give me 1 kg of sugar along the east direction. So you don't need to tell anybody that you need a body of a certain mass along a specific direction. You just need to tell give me 1 kg of sugar. Similarly, unit of time is second. So you will never say 2 seconds along east, 1 second along west, etc. So this means that scalar quantities do not require direction. They are simply defined on the basis of magnitude, and the work is a scalar quantity, so work do not require any kind of direction. Unit of work is joule. Since you know that work W is force time displacement, so W, the unit of force is Newton, and whereas the unit of displacement is meter. So the unit of work become Newton meter. When a force of 1 Newton is applied on a body, which result into a displacement of 1 meter, then the work done on a such body is known as 1 joule of work. Suppose this is a black block having a mass m. If a force, suppose that force of 1 Newton is applied, 1 Newton is applied on this block, and this block cover a distance of 1 meter due to application of the force of 1 Newton, then the work done on this block of mass m is known as 1 joule. So 1 joule is equal to 1 Newton into 1 meter. Now, students, other type of unit of work are unit of work are foot, pounds, and also erg is also a unit of work. Dear student, please keep in mind that 1 joule SI unit of work is joule, but SI unit of work is also kilogram meter per second square. Now let's discuss that how both the SI unit joule of work, how they are related to, how this value is related to kilogram meter per second. As you know that work is force time displacement, and according to Newton's second law, force is ma. We can write in this in different color. According to Newton's law, force is equal to m into a. Then work become W will become m into a into displacement. Consider this as equation number 1. As you know that acceleration is a change of velocity in unit time, or it is a rate of a change of velocity. Unit of velocity is meter per second, and whereas the unit of time is second, so this means that unit of acceleration is meter per second square. Then this equation 1 will become, work will become, as you know that the mass, unit of mass is kilogram, unit of acceleration is meter per second square, and unit of displacement is meter. So the work becomes kilogram meter square per second square. This means that joule, which is also unit of work, is equal to kilogram meter square per second square. So now, dear student, let us discuss about the dimensions of work. As you know that work W is equal to force into displacement, and force is equal to MA into displacement. W is equal to M, which is MS. It will be, as you know that it is in kilogram, whereas acceleration is in meter per second square, and D is in meter. So this means that work W will be equal to kilogram meter square per second square. Then work, dimension of work become, as you know that kilogram meter square per second square. Then kilogram is a representation of a mass. So this dimension of mass will be a capital M, whereas meter square is representation of a length, so it will be L square, and whereas the time, the second square is representation of a time, so it will become T square. So W will become, dear student, in dimension it will become capital M L square divided by T square, and you can write it as W is equal to M L square into T minus square. So this is the representation of a dimension of work. So now, dear student, let us discuss about the types of the work. Work is defined on the work is represented, or work is based on. So the work is divided into two main types. First type of work is known as positive work. Second type of work is known as negative work. So now, student, what do you think? What is positive work? Positive. As you know that, as I previously defined that work is a scalar quantity, it is a dot product of force and displacement, and the angle between the force and displacement is cos of theta. So work will be F into D cos of theta. W is equal to F D cos of theta. Now, if angle theta between the force and displacement vector force and displacement vector is 0, or if force vector and displacement vector are parallel to each other, then the work done on a body is known as positive work. Since you know W is equal to F into D cos of theta, if the angle of theta between force and displacement vector is 0, or if force is parallel to this displacement vector, and if both the force and displacement vector are along the same direction, then W is equal to Fd cos will become Fd cos 0, and work will be equal to F into D. So work will only depend on a force and a displacement on a body, and this kind of work is known as positive work. We can represent a positive work with a schematic diagram like this. Consider this is a body of a mass M. Now, if suppose that force is applied on this body of mass M along this direction, and if this block move along the same direction as where the force is applied, like this, like this, then the work done, since the force and this d vector both are parallel and the angle between both the force and displacement vector 0, then the work done on this block will be positive work. Second type of work is known as negative work. Negative work means that if the angle between the force, suppose that this is a force, and displacement d is 180 degree, theta is 80 degree, then the work done on a body is known as negative work. Suppose that this is a block and the block has a mass m. Now, and suppose that force on this block is applied along this direction, but this block moves along the opposite direction like this. So the angle between the force and displacement becomes 180 degree. So in such case, the work done on the block will be negative work, and W is equal to F into D cos of theta will become F into D cos 180 degree. So work will become, as you know, that cos of 180 degree is equal to minus 1. So the work will become, W will become minus F into D. Just keep in mind that work may be 0. How? You can say that work is 0. 0 work. If angle between force and displacement vector become 90 degree, then the work done on such body is 0. Consider this as a block of mass m. Now if the force is applied along this direction like this, F is applied along this, the displacement direction of displacement is like this, then the angle between a force and displacement become 90 degree. So this means that the work done on such block will be 0 and block will remain in a rest position. Since W is equal to F into D cos of 90, cos of 90 is equal to 0, then this means that work is equal to 0. So no work will be done in this condition if force and displacement vector are perpendicular to each other. Now let us discuss about the SI unit and a non-SI unit of work. International standard unit of work is joule, whereas non-SI unit of work are Newton meter, arc, foot pound, foot poundel, kilowatt, R, liter atmosphere, horsepower or horsepower or etc. As you know that I have previously discussed that 1 Newton force applied on a body of having a mass result into a displacement of 1 meter is equal to 1 joule of work on a body. Similarly, dear student, 1 arc is a unit of a work in CGS system. One arc is equal to 10 raised to power minus 7 joule of work. CGS system is an abbreviation of centimeter gram second system, and in centimeter gram second system, one arc is equal to 10 raised to power minus 7 joule of work. Okay. Similarly, the student is foot pound force is a unit of work. Foot pound, okay. Foot pound force is also a unit of work, which is represented by Ft into LBF. It is the unit of work in engineering and gravitational system. It is the energy transferred upon the application of force of 1 pound force through a linear displacement of 1 foot. If we apply a 1 pound of force and which result into a linear displacement of 1 foot, then the work done will be 1 pound foot force. And this is further corresponded to, or this is further converted into a standard, joule. Okay. Similarly, kilowatt is 1000 watts per hour. Liter per atmosphere is a liter in atmosphere, and horsepower per hour mean power in hours. So basically we can convert them into a joule and we can correlate those. So in a simple word, dear student, work, SI unit of work is joule, whereas non-SI units of work are Newton meter, arcs, foot pound, foot poundal, kilowatt hours, liter atmosphere, horsepower hour.